For lesson 1.5, our goal is to find the displacement and total distance traveled on distance graphs. This is something that we're going to need to connect to velocity later in order to start understanding integration. When you look at a distance graph, the distance is represented often by the changes in y over the course of some time period that is on the x-axis. If you were to add up all of the changes that y has over the course of a single graph, the result would be the displacement, which would tell you how far away you ended up from where you started. This is, of course, assuming that you regard changes in the opposite direction from what's regarded as away as negative, or rather anything with a negative slope on the graph. If instead you took the absolute value of those vertical changes and you just added everything together as a positive number, the result would be the total distance traveled. A very brief example of this is if you were to walk 10 miles away from your house and then 5 miles back toward it, you would have a displacement of 5 miles, but a total distance traveled of 15, because you traveled 10 away and 5 back towards. So for our two examples here, we've got one graph with a positive line, a flat line, a negative line, and another flat line. So our first change in y is going to be from 0 to 5, so that's going to be plus 5 here. Our next line has no change in y, so that will be plus 0. Our next line moves down 2, so that is going to be a change of minus 2. And our last line also has a change of 0. So ultimately for our displacement, we just end up with 5 minus 2, which is 3. If we were to take these same numbers, but turn our negative 2 into an absolute value, we would end up adding our 2 instead of subtracting it, meaning that we actually had a total distance on this graph traveled of 7 units. On our other graph over here, our starting point is actually pretty high up on the graph. It looks like it's at 4, 5, 6, 7, 8. And by the time we get to the end of this line, we're all the way down here at 2. That means we have a downward change here of minus 6 units. This is a flat line, so that's 0 unit change, and this is actually down another 2. Meaning our displacement for this is actually negative 6 minus another 2, which is negative 8. But technically, even though we moved back towards the origin of the graph, in total we traveled 8 units, and we can get there by taking our absolute values. Pretty simple concept. It's just important to make sure that you know the difference between the two when you're talking about them. You might have also heard these words used in one of your science classes or physics or biology, maybe even. I don't know. I'm not a science person. Anyway, let's take a look at the Desmos file. Because we're just adding and subtracting numbers for this lesson, the Desmos file just has the exact same notes that you want to remember for the difference between displacement and total distance here. If you do want to use the Desmos file to take absolute values, you can do so by typing ABS and then putting the number you want to have the absolute value of in parentheses. It's just always going to turn it positive though, so I don't know. It's up to you if you really want to use it. Keep in mind that in an actual math situation though, absolute value is written by putting 2 vertical bars around something. They don't have this as a command for absolute value in Desmos, but if you were writing this out on paper, just like I did on my example in Paint, that you would use these 2 vertical bars. That's all. Like I said, next lesson we'll be tying this to velocity, so see you soon.